An account grows by 6% per year compounded monthly. So how long will it take for the account to double in size? So we're not given a starting amount, but we just want to take whatever we start with and double that amount in size. So remember that we had the formula for compound interest that told us that the amount that you'll have at the end is equal to the initial amount times 1 plus r divided by k, where k tells us our compounding period, to the power of k times t, where t is the number of years that we're looking at. So in this particular problem, we're given a few of these values. We're told that our interest rate is 6%, so we'll use this as the decimal, 0.06. And then we're told that we're compounding monthly, so k is equal to 12. We're just going to use our initial value as a. So then our ending value, since we want to double, is going to be 2 times a. And time is the unknown thing that we're trying to solve for. So let's plug these into our equation. So our ending amount, 2a, is equal to a times 1 plus 0.06 divided by 12 to the power of 12 times t. So we can begin by dividing both sides by a to get a simplified equation that 2 is equal to, if you put in your calculator 1 plus 0.06 divided by 12, we find that's the exact decimal 1.005 to the power of 12t. The variable that we're trying to solve for is in the exponent, so to solve this exponential equation, I'm going to introduce a log on both sides. So I'm going to go ahead and use the natural log of the left-hand side and the natural log on the right-hand side. Our properties of exponents inside of a log tell us that this power of 12t can now move out in front as a coefficient. So we'll have the natural log of 2 is equal to 12t times the natural log of 1.005. We're trying to solve for t here, so we want to get that by itself. The 12 and the t and the natural log are all multiplied together. So to isolate that t, I can divide both sides by 12 and the natural log of 1.005. So we'll find that t is equal to the natural log of 2 divided by 12 times the natural log of 1.005. If you are putting this in your calculator all at once, be sure to put parentheses around that entire denominator so that your calculator knows that both of those factors are together in the denominator. So plugging this in, we get that t is approximately 11.58. The time when we're using our compound interest formula is always measured in years. So we're using k equals 12 since it's 12 months per year. So this time frame would be in terms of years. So if you have an account that grows by 6% per year compounded every month, if you want to double the amount of money in that account, it'll take a little over 11.5 years.